Good morning, Samantha. Good morning, Wesley. How are you guys doing today? Ooh, I better turn on the session settings. Let's see here. All right, you guys should have session settings now, so you should be able to chat. How are you guys doing today? Awesome. About 15 minutes ago, it was getting a little too cold outside, so I came inside because I like being outside, and now I see it's pouring out. So I am so glad I moved inside because my computer would be getting really wet right now. All right. Well, it looks like Wesley has to go in and come back. Yep. Anytime that your volume doesn't work, you should go out and come back. All right. Again, my name is Mr. Shanklin. This is pre-college math. Let's get going. Let's see here. This week we're going to be dealing with complex numbers. Complex numbers for some kids a difficult thing. You should have seen this in Algebra 2. I know when I teach Algebra 2, we always go through complex numbers. Just a little bit of a review before we go on to the practice problems. It says the imaginary unit I, we've learned that some quadratic equations have no real solutions. For instance, the quadratic equation x squared plus 1 equals 1, x squared plus 1 equals 0 has no real solution because there is no real number x that can be the answer to negative 1. So for example, if I wanted to solve this thing, usually what I would do is I would just go x squared is equal to negative 1, then you take the square root, and we were always told that if you have a square root of a negative number, you have no solution. However, that's if you're dealing with the normal standard real numbers. But if we're dealing with imaginary numbers, oh, absolutely, we can have an answer. And this is the most important thing that you have to remember this week, that I, the square root of negative 1 is I, and I squared is equal to negative 1. Those are the two really, really, really important things for this week that you need to know. All right, and then we're going to deal with a lot of different stuff this week. All right, so I'm going to give you the Desmos presentation. So here, whoops, that did not work. All right, so here's the Desmos presentation for today. So if you guys could just log into that. I should go back because I really need that. Okay, so there's the code. Okay, so get on in there, and then we're going to do the practice problems for this week and see how you guys do. There's some really good problems on the practice this week, I think. All right, I got to go into Desmos and see. Oops, I forgot to. Oops, I need to get into Desmos also. If I don't get into Desmos, I can't watch. All right, so here we go to practice. Okay. All right. Okay, so what I want you guys to do is I want you to go to slide number, what number is that I want you guys to start on? We want to start on slide number 4. That is the first problem on this week's practice. Okay, should be a fairly easy problem. It asks us, it says evaluate the expression, the square root of negative 25, and write the results in the form a plus bi. Choose the answer from the following. Okay, so I am going to go into Desmos and see how you guys are doing there. See what answers you guys chose. So we have 6 students here. Let's see here. All right. So I have a couple students working on it right now. Awesome. Thank you. And some kids just circled the answer, which is perfectly fine. I mean, some of you look at these problems like, Mr. Shanklin, there's not a whole lot of work to do on these. I agree with you 100%. There probably is not a lot of work that you have to do here. Most students can look at this and say, hey, my answer is, blah, okay, or whatever it is. So if I was going to do this problem, and I'm going to do it right now on the board. So I have the square root of negative 25. I always tell students anytime you have a square root of a negative number, the first thing you should always do is you should rewrite it without the negative inside. So how do you do that? You just rewrite it as the square root of 25 That just means that there's an imaginary answer. Well, the square root of 25 is just 5, so my answer is just 5i. The answer should be letter A. Now, isn't it weird that they ask us to write it as A plus BI? This is complex form, okay? And if the A value is 0, which it is this time, because there's no real part to this problem, there's only an imaginary part, you could write it as 0 plus 5i if you wanted to, or you can just write it as 5i. Makes no difference. When there's a 0 for the real part, you just leave off. All right, next problem on the practice for this week, we have, boy, I can barely read that. Are my eyes going really bad, or is that just really small? Oh, I am really, really sorry, guys. I am not sharing my screen, so you cannot see what I'm writing. No, I hate when I do that. Let me see here. I'm going to go back to here. Okay, so, and I wasn't reading the comments either, so I better go back and check that out. Plus or minus, shouldn't it be plus or minus 5i? And the answer to that is no. Because, this is the reason, only when you solve, like when you have something like x squared is equal to 25, and then you take the square root of both sides, then you have to put plus or minus in there because it is x squared. I'm going to write on the board now, so hopefully you guys can see me writing on the board. I'm going to go back, because you guys probably did not see this previously. Okay, so this is what I wrote last time. So if you're looking at the Collaborate, you should be able to see what I did. But that's a good question. If you ever have something like x squared is equal to 25, and then you take the square root of both sides, then you have to say, hey, my answer is x equals plus or minus 5. And the reason we do that is because if you put 5 back in here, the original equation was this, right? So 5 squared is 25, and negative 5 squared is also 25. That's why we come up with two solutions when we do a quadratic. But if you're just taking the square root of a number, you don't do that. You don't put plus or minus in there because it's not both positive and negative. It is just the square root of that number. But when you're solving a quadratic and you get x squared and you take the square root of both sides, then you have to say, hey, positive and negative are my solutions. Does that make sense? Why we wouldn't put plus or minus in there? Hopefully that makes sense. Okay, so now problem number 2. Let's go to problem number 2 on the practice. It looks like it says 14 plus 20i plus 19 minus 2i. Now this is you can do addition, subtraction, multiplication, and division with complex numbers. Okay, and that's basically what this problem is asking for. Do you know how to add complex numbers together? Well, it's fairly easy to do. All you do is you add the real numbers together, you add the imaginary numbers together, and voila, you have your answer. So if I was going to do this problem, I'm just going to add the 14 and the 19. Well, that gives me what, 33? Plus, and then if I add 2i minus 2i, well, to me, that's just 18i. So my answer should be 33 plus 18i. That's it. That is my answer for that problem. Okay. Any questions on that? Imaginary numbers or complex numbers, you can add, subtract, multiply, divide. Now, when you divide, it gets a little bit more complicated. I will tell you that. There is no question when you divide complex numbers, they are much harder to do. Okay, we'll talk about that a little bit later when we talk about the assessment. All right, let's check out problem number 3 on the practice week. And I am going to let you guys do this problem. I am going to, I think a lot of you are going to get this wrong. Okay, and that's just me because I've been doing this for 35 years and I know where kids are going to make their mistakes. So I'm going to let you guys, I'm going to stop talking, which is very unusual for me because I love to talk. I'm going to stop talking. I'm going to let you guys work on Desmos. And I'm going to let you guys, and for anybody that's new, that just came in, there's the Desmos link. And I'm going to let you guys do this problem. Okay, so this is slide number 6. I'm going to just stop talking and let you guys work. All right. I am smiling. A lot of good work. However, not a lot of correct answers. Yeah. And the reason is there's a lot of different reasons, but this is new stuff for a lot of students. I saw a lot of students do this. They did negative square root of 25, which is the square root of 25i, which is 5i. I agree with that. That is absolutely correct. The square root of negative 25 is 5i. Okay, so I've got 5i here. Times, well, then I saw a lot of kids do this with the square root of 81, negative 81. They rewrote it as the square root of 81i, which is 9i. I agree with that. So a lot of kids did this. And then a lot of students said, oh, my answer is 45i. Not a chance. If I gave you 5x times 9x, you would not say that's 45x. You would say that's 45x squared, right? That's what your answer would be. Because when you multiply variables, you multiply the variables. So this should be 45i squared. However, you can never leave an answer. I'm going to repeat this. You can never leave an answer with an I that has a power on it. That is not legitimate. You can never have an I with a power on it. Well, then how do I get rid of the I squared? Well, remember, in the beginning of today, I said there's two really important things. The square root of negative 1 is I, and I squared is 1, or negative 1. Sorry about that. So when you have I squared here, you need to rewrite this as negative 1. So this is really 45 times negative 1. So my answer is negative 45. All right. That is a lot of stuff that I just went over, okay? Any questions on how I came up with negative 45 for an answer? Does that make sense to you guys? Okay, that I squared, that is negative 1. So you have to make sure that you rewrite that as negative 1. All right, sweet. Let's go on to the next one. So the next slide we have, and I wish I numbered these so I would know what they are. Oh boy, this is a tough one because now they're asking us to multiply. So that means I have to do FOIL, right? I've got 4 plus 7i times 7 minus 3i. Whoo, that is a good problem. I am going to stop talking again, which again is very difficult for myself because I love to talk, and I'm going to let you guys work on this. So please go to slide number 7 and work this problem out. All right. Um, I think you guys are getting it. It looks like the work with you got the right idea now. This is okay. So FOIL, most students know what foiling is. You just multiply. I just do double distributive property. So I've got 4 times 7. Well, that's 28. 4 times negative 3i. Well, that's negative 12i. Then I've got 7i times 7. Well, that's 49i. And then I have 7i minus, okay, so 7i minus or times 3i, well, that's 21i squared, right? Well, I can add these two middle ones together, can I? Because same variable. So I've got 28, and then what is that? 49 minus 12, so it's going to be 37. So this is going to be plus 37i minus 21i squared. Well, I squared is negative 1. So negative 21 times negative 1, that's 21. So that's really plus 21. So now I have 49 plus 37i. Awesome problems. The I is the only thing that is different than what we've always done, the I squared. You know, if I would have just put an X in there, we would have did the same steps. It's just we would have ended up with an X squared in our answer, right? But in this problem, we end up with an I squared, which we have to change to a negative 1, and then boom. But it looks like I've got 1, 2, 3, 4, 5 right answers. Awesome. Well, I suppose one of them is mine. I hope I got it right. All right. So the next problem, this is one of the most difficult problems there is, okay? Whenever you're trying to get rid of, and obviously this would be a proficient problem on the assessment, we have 106 divided by 5 minus 9i. One of the rules, I told you, one of the rules is you can never have any I in your answer that is more than I to the first power. You can't have an I to the second, you can't have an I to the third, you can't have an I to the fourth. The other rule with imaginary numbers is you cannot have an I in the denominator. Who made up these rules? I don't know who made up these rules, but those are the rules. So we can't have an I in the denominator. So how do we get rid of it? There's only one way. You have to multiply top and bottom by the conjugate. Somebody's like, I don't even know what the conjugate is. How am I supposed to multiply top and bottom by? You have to multiply the top and bottom by the conjugate. So this is what I'd have to do on this problem. I would have to multiply the top and bottom by 5 plus 9i. And somebody's going to say, well, why the heck would you do that? What did I just say? I said you can't have an I in the denominator. Well, if you had something like x squared minus 9, and I asked you to factor this is a difference of two squares. It factors to x minus 3, x plus 3, right? What happened to the middle term? Goes away. What happens to the outside term? You square it. Well, guess what? Same thing here. If I did FOIL on this problem here, I'd end up with 5 times 5, so that's 25. Then I'd end up with plus 45i minus 45i. Oh, those two terms are going to cross out. And then I'm going to be left with negative 81, negative 81i squared. Well, guess what? These cross out. This I squared becomes negative 1. This becomes positive 81. So now I have 25 plus 81 on the bottom. 25 plus 81, 25 plus 81 is going to be 106. Holy cow. So this whole bottom becomes 106. That's it. The i's are gone. So guess what? Now this 106 crossed out with this 106. My answer is 5 plus 9i. Whoa, Mr. Shanklin, that is some math magic there. Trying to get rid of the I in the denominator. So anytime, now this does not always, if I gave you a problem like this, if I gave you, and I said, okay, I want you to, I have 5 over 9i, and I want to simplify. I want to get rid of the I. Well, you don't have to multiply by the conjugate now. All you have to do is multiply top and bottom by I, right? Because 9i times I, well, that gives us 9i squared, which gives us negative 9 on the bottom. That just gives me 5i on top. But when you have two terms, then you have to multiply by the conjugate. And that was some pretty cool math there, I thought. I mean, I know I'm a math nerd, kind of get into this stuff, but does that problem make sense? Because I can tell you that would be one of my proficient type questions that I would ask. It's like, how would you get an answer like that? Does that make sense? You guys think you could do that? All right. I love those types of problems. They really test your knowledge. It's a good type of problem. So are all math signs negated? So -1 would become positive. Not 100% sure, Wesley. I understand your question. Not sure.
What I mean by that is, like, when you're doing the problem here, it was multiplied by the conjugate, where it was originally
I mean, you can
5
absolutely
9i.
use the microphone too if you want to ask a question, but I'm not 100% sure I get your question. So are all math signs negated? So negative would become positive. If you're doing a conjugate, it would be. Like if I asked you, let's say I gave you a problem like, if I gave you, let me get rid of this. If I gave you a problem like 5 over, let's go 3 plus 4i. Well, then you would have to multiply top and bottom by 3 minus 4i, because when you multiply this together, you'd end up with 9 minus 16i squared, which is positive 16. So you'd end up with 25 on the bottom. So I don't know if that answers your question, but when you do the conjugate, it's pretty easy when you start thinking about it, because the middle term's always going to cross off. Okay. Yep. All right, let's go on to the next one. Now here's one for you guys to do. So I've got 96 minus 64i over 4 minus 4i. So I want you guys to work on that. Okay. See what you get. And then I'll go through it and see what I get. All right, I'm going to stop talking and let you guys work. All right, let's try this one. First thing I always do in a problem like this is I never try to do the top first, okay? I know I have to multiply top and bottom by 4 plus 4i, okay? I know that. I don't do anything with the top because sometimes the top and bottom will just cross off, so I just leave it. So now if I know that this is always going to be the two first numbers, so that's going to be 16. The middles are going to cross out, so then I'm going to end up with the negative 4i times 4i at the very end, so that's going to be negative 16i squared. So everything else is going to cross off. The middle is going to cross off. So this is really going to be 16 plus 16, isn't it? Or 32 on the bottom. So I end up with 32 on the bottom. I'm going to take a look and see how many people had 32 on the bottom, because that's the first place that I would start, is I'd try to get the denominator. So now I've got the denominator. Can I factor out a 32 here? 96, I think I can. I think I can factor out a 32 there. So 96 divided by 32 is 3. So I can factor a 32 out of here, so I'm going to do, oops, I'm going to factor a 32 out of the top. So that gives me 3 minus 2i, and then 4 plus 4i, right? And then I have a 32 on the bottom. Well, those are just going to cross out. So I'm going to say my answer is going to be this. Now, did they make, oh, yeah, they made us multiply it out. Yikes. All right. So I can do that. That's not a big deal. I can do that. So if I multiply this out, I end up with 12 minus 12i, and then minus 8i, and then negative 2 and 4. So that's going to give me negative 8i squared, which is plus 8. So it looks like I end up with 20 minus 20i. Is that right? Is there an answer like that? No, there's not. I made a mistake someplace. Darn it. What did I make? 12. That's 20. Oh, one of these is probably a positive, because that would do it. Okay, so where did I make my mistake here? So if I multiply across, I end up with 12. Oh, that would be a positive 12i. So that's going to be positive 12i minus 8. So that's 4i. So that's going to be 20 plus 4i. Sorry about that. A little bit out there. Okay, so it should be 20 plus 4i. Okay, does that make sense? The bottom is the most important because you can't have an I in the denominator, so we've got to get rid of that. Okay, that is when you look at a problem for imaginary numbers, that is what I would consider an advanced problem. Okay, you really have to know what you're doing in order to get those answers. So that would be considered an advanced problem. All right, let's try the next one here. Now this one is way easier. This one you don't have to multiply through by the conjugate, okay? Because I have 12 plus 6i over 2i. Well, if I just multiply top and bottom by I, because remember, what is our goal? Our goal is to get the I out of the bottom. Well, if I did that, 2i times I is 2i squared, which would give me a negative 2 on the bottom, okay? And then if I multiply this, I'd end up with 12i, because I've multiplied the I by everything, so 12i plus 6i squared, which is negative 6, isn't it? Now, lo and behold, they probably factor out a 2. They probably factor out a negative 2. So that would give me negative 6i plus 3 over negative 2. Those cross out. Negative 6i plus 3, or 3 minus 6i. I would go with letter D. I love these types of problems because it really makes you think about what's going on. You got to get rid of the I in the denominator. So that takes care of it. Okay, any questions on that one? That was a little bit easier, except at the very end when we had to factor out the negative 2 to get rid of that negative 2 on top and bottom. That was a good problem. Some really good problems this week. I really enjoy the imaginary number kind of things. All right. Oh boy. Whew, I don't even think I'd put a problem like this on a Holy moly. Holy cow. That is a beast of a problem. I am, oh, wow. I'm looking at this problem. It's like, wow. Because it's a subtraction problem, so it's a fraction. And I'm looking at it, it's like, well, you can't have an I in the denominator, but you have to get a common denominator first. So my common denominator for this problem, if I was looking at this problem, I would look at this and I'd say, okay, I've got 208, and then my common denominator is going to be 5 plus I, 5 minus I. That's going to be my common denominator. So here I have to multiply, so this is going to be 5 plus I, 5 minus I. So I have to multiply that by 5 minus I on top, minus, and then I have 104 here, and my common denominator, so I have 5 minus I. So I have to multiply by 5 plus I, and this would be 5 plus I. Whew. I'm going to multiply the 5I times the 5 minus I on the bottom. I just want to get rid of that. So 5I plus, or 5 minus I, so if I FOIL this out, I should end up with 25 minus I squared, which is plus 1, right? So this is 26 on the bottom. So I have 208, 5 minus I, over 20, what did I say, 26, minus, and then I have 104, and then 5 plus I, over 26. Now, do these simplify out? 208 and 26, does that simplify down? Because I'm going to assume it does, but I'm not 100% sure. So I'm just going to go to my trusty calculator, which is just my phone. And my phone doesn't want to turn on. What the heck? All right. Something's wrong with my phone there. So let's try this. No, it's not working. Okay, somebody who has a calculator, does 26 go into 208? 8 times? Okay. And how about the other one, about the 104 and 26? Does that come out too or not? So this is going to be 8, 5 minus I, minus, and then the 26, does that go in there 4 times? Okay, well, that makes sense because it's half of 208. All right, so this is going to be 4, 5 plus I. Okay, so now it's not so hard. So if I multiply this across, I get 40 minus 8I minus 20 minus 4I. So that's going to be 20 minus 12I. Whew. 20 minus 12I. Whoa, there is an answer. Yay! That is quite a problem. Those, as I said, I would consider those to be advanced problems. Anything with an I in the denominator, it's going to be something. All right. Now the next problem I'm thinking is a lot easier. I to the 45. What is I to the 45? I to the 45th power. What is my answer? All right, I'm going to let you guys work on this one because this is a much easier problem. Okay, so this is slide number 12. We should be on now. Okay, slide number 12. I to the 45th. What is my answer? Oh, I can tell somebody watched my lesson tutorial. I can see 2 of you guys watched it. And why do I know that somebody watched my lesson tutorial? Because they're dividing by 4 right now. Anybody that's dividing by 4 understands the lesson tutorial. Love it. Love you guys, because it does help. And the reason it helps is because when you think about this, the first thing you have is I, then you would have I squared, and then you would have I to the 3rd, and then you'd have I to the 4th, and you could have I to the 5th, and I to the 6th, and you could just keep going on and on and on. And I want to know what I to the 45th is. Well, I squared is negative 1, right? So you have I, and then you have negative 1. And then I to the third really would be I squared times I, which is negative 1I. And I to the fourth would really be negative 1 times negative 1, which is 1. And then then this keeps repeating. So I to the fifth has to be I to the sixth has to be negative 1. I to the seventh has to be, what is that, negative I. And it just keeps going like that. It just keeps repeating. So what I taught in the lesson this week is that if you have something like, let's say I to the seventh, we know what the answer is. We know it's negative I, right? So if you take the power and you divide by 4, what is the remainder? Well, 4 goes into 7 one time. The remainder is 3. Okay? So remainder 1, 2, 3, 4. So if the remainder is 1, your answer is I. If the remainder is 2, your answer is negative 1. If your answer is 3, remainder 3. That doesn't work, does it? Did I think I did something wrong here, because it was 0, 1, 2, because you can't have a remainder of 4, because 4 would just go in there, right? Darn it, what did I? Maybe I started off with 0. Darn it. Okay, because you just have to look at the remainder, and the remainder is going to tell you what your answer is going to be. Okay, so what is my answer for I to the 45th? If it's divisible by 4, then it is 1. Okay, if it's divisible by 4, then it's 1. Is that, all right, so then it's 1. Okay, that makes sense. Okay, so what should my answer be here? So if we had 45, divide that by 4, what's our remainder? Is that a remainder of 1? Because 44 goes in there. So what would my answer be there? So if my remainder is 1, then my answer is just I for that one. Okay, so it makes it really easy if you understand how to divide through, because it's just the remainder then that's going to give you your answer. All right. Oops, I'm on the wrong slide here. How about this one? Evaluate the expression I to the 44th power. Okay, so I think I messed this up, if I'm not mistaken, because there's going to be a remainder of 0 here. So I think this is remainder 0, remainder 1, remainder 2, remainder 3. I think that's how it goes, and then this would be 0, 1, 2. That doesn't. Okay, so remainder 2 would be negative I. Okay, so that makes sense. This would be remainder 0, remainder 1, remainder 2, remainder 3, and then it starts all over again. 0, 1, 2, 3. Okay, so in this problem, in the next problem that we had, we have a remainder of 0, right? So our answer should be, the remainder is 0. Our answer should just be I, shouldn't it? So I'm going to go back. I'm going to go back to the previous one. Okay, so I don't want to mess you guys up. So I'm gonna do this all over again, because I think I messed things up here. All right, so we have I. We have I squared. We have I to the third. We have I to the fourth. We have I to the fifth. We have I to the sixth. I to the seventh. Dot, 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 dot. Okay. I believe this is remainder 0. Okay, so I'm just going to rewrite this. So this is I, negative 1. Then we would have negative I. Then we would have a 1. And then it just keeps repeating, doesn't it? So I to the fifth would just be I. I to the sixth would be negative 1. I to the seventh would be negative I. I to the eighth would be negative 1. Oh, did I mess up here? So I've got I, negative 1, negative I, 1. I, negative 1, negative I. I did I up there. I to the 8th would be, so negative 1, so that would be 1. Okay? Is that right? So I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 0, so this would be 1, 2, 3, 0. Is that right? That is really not making sense to me. All right. So my answer for I to the 45, so we said that was a remainder 1, right? Remainder 1. So we said that our answer was I, correct? Am I on the right page here? Because I'm messing up on my thing. So 44, I to the 44th would be positive 1, because that's a remainder of 0. See, I think I've done this differently. I think I started with 0 as that. So that's what's really messing up my head here. So I to the 44th, we're saying is, so that would be 0, so that's 1. Are we agreeing with that? Yeah, so it should be 1, because it's, okay, all right. Okay, I think I'm messing myself up with these. All right, so let's go on to the next one. Hopefully there's no more of those. Oh, I guess we did all the practice problems. Okay, so practice problems done. What is going to be on the assessment this week? Okay, so the beginning of the assessment is just going to start off with a problem like this. Simplify the following. I to the 66th. Okay, now this is where students don't look at the recordings or anything, because if you give me an answer, something other than I or negative 1 or negative I or 1, these are the only 4 answers you could give me, right? Because I to the 66 could only be one of these answers, correct? There cannot be anything else. So what is my answer here? I to the 66th is what? Okay, what is my answer? I to the 66th. So we're going to divide by 4. What is our remainder when we divide by 4? Remainder of 2. So our answer is negative 1. I agree. Okay, that is the very least I expect from you guys. This is the minimal type questions. All right, so then how do we get harder? Okay, well, the other types of problems are like this. They're going to be adding and subtracting. So 6i plus 4i, my answer would be what? What is 6i plus 4i? 10i. Done. Now, you're going to have some subtraction. You might have some multiplication in there. So, for example, if I gave you something like, let's say I gave you something like 3i times 4 plus 5i. That would be, I would assume that this is an approaching type problem also, that you can do all of the arithmetic addition, subtraction, multiplication on this. So if I just multiply this through, that would give me 12i plus 15i squared. Well, you can't leave an I squared, so this would be 12i minus 15. Done. That is what I'm expecting students to be able to do for approaching. Now, for advanced type problems, well, the advanced type problems, that's not an advanced problem. I would expect students, that was last week, I would expect students to be able to do something like this. simplify 2 over 3 minus, let's go 4i. That I would expect to be an advanced problem, okay, where you have an I in the denominator, and in order to get rid of that, we have to multiply through by the conjugate. So I would multiply this by 3 plus 4i. If I multiply the bottom out, and I always do the bottom first, so that's going to end up being 9 minus 16i squared, which is 9 plus 16, which is 25. And then the top, I might just rewrite that as 6 plus 8i. That is what I would, that is an advanced problem, where you have to get rid of the I in the denominator. All right. Any questions on any of those? Any questions on anything for this week? This week basically deals with imaginary numbers. You're adding, you're subtracting, you're multiplying, and you're dividing. Any questions on any of that stuff? How would I get 25? Okay. Are you sure? I can go through it. You see it? Okay. Yeah, because I just did the FOIL, and I know that when I'm going to do a conjugate, the middle is going to cross out. So I only really have to do, when you think about it, when you're doing these types of problems, you only have to do the inners, or you just have to multiply here, and then you have to multiply here. Those are the only two things that you have to multiply, because the middles are always going to cross off. So I just ended up with 9 minus 16i squared. 16i squared is just 16, and that would give me the 25. All right. Any other questions on any of that stuff? All right. You guys have a great week. It's going to be a little bit colder than it has been in the past. All right. Bye.